So to wrap up this section on the normal curve, first we're going to talk about assessing normality, and then we'll move on to other things such as how to find the proportion or area underneath the curve. So let's look at assessing normality. If we want to determine if a curve is normal or a data set is normal, one of the things that we can do is we can use our calculator. We can use the TI-84. And what we would do is we would plot a normal quantile plot. And we want to see if the data is linear. And the example I have here, the data is approximately linear. Therefore, the data that it came from is approximately normal. To find this on your calculator, you hit second, y equals, and that's your stat plot. And then you can just, if you look over on the screenshot, you can see the last graph on the right-hand side. That's the type of graph you're going to select. Select which list your data comes from, and then graph it. And again, the more linear the data, the more approximately normal the data set is, or the data came from. So that's one way of assessing normality. The next thing we're going to learn how to do is find area under a curve. And we already learned one way, and one way was by using Table A. And Table A was the table in the front of the book. But now we're going to go over how to use the TI-83. And when I say TI-83, I mean either the 83 or the 84. Not the 89. If you want to use the TI-89, look in your book. That's the one I don't help you with. I'll help you with the 83 or 84, but I'm not familiar with the 89. So here are some things that you need to do. You press second and the vars key, and then you select normal CDF. It's very important we select the right type of distribution, and for this class we are always going to use the normal CDF. And that's cumulative density function is what it stands for. If it doesn't prompt you, which it may or may not, it's left bound, right bound, mean, and SD is standard deviation. And then less than or greater than, use very large values for left or right bounds. We'll talk a little bit about this, and then we'll discuss it more in class if you have any questions on that. Here's the same thing, but this is a screenshot so I can show you where you can find the second key and the vars. So second vars, and that'll bring up something either to prompt you, or else it'll say normal CDF, and you'll have to enter left bound, right bound, mean, and standard deviation. So let's look at a problem and apply this directly. I actually skipped that step. I'll put it someplace online. It's just a problem, but we'll go over it again, so I'm not that concerned that we have it now. Here are the steps for finding normal proportions. You should be very familiar with these steps by now, because you should have written them down. So let's work a problem using the calculator. It said Max's customers put money for charity into a collection box in his shop. The average weekly collection is approximately normally distributed, with a mean of $40 and a standard deviation of $6. And then it says in a randomly chosen week, find the probability of Max collecting between $30 and $50. The first thing we have to do is state the problem in terms of the observed variable x. I'll do that for you. And you should be able to do this for yourself as well. And then how I like to write these between problems, I say x is between. I have 50 here and 30 here. I think x is greater than 30. X is less than 50. That's how I'm going to state the problem in terms of the observed variable x. Let's look at step 2. Step 2 says to graph the distribution. Okay, I can do that. So I see it's approximately normally distributed. The mean is 40, and the standard deviation is 6. Okay. So I'm going to go down here. I'm going to graph the distribution. Don't hate on my beautiful graph. The center of this, the mean, is 40. That's beautiful. 50 and 30. And this is not to scale. This is just a quick sketch more so that I can kind of get a feel for what we're looking for in the data. And let me shade this in so I remember what it's between. So my graph should look something like this. So I'm looking for everything between 30 and 50. Okay, let's take a look at step 3. Step 3 says to find the proportion or area under the curve. And here I've already done this for you. I've showed you what the distribution menu looks like, and it's normal CDF. Again, we never use normal PDF in this class. If you use normal PDF, your paper should catch on fire. If it doesn't, your calculator should. But in all honesty, normal PDF in class is not at all important and not relevant. So when I push this in, my lower bound is 30. My upper bound is 50, or my left and right bounds are 30 and 50 respectively. My mean is 40, and my standard deviation is 6. If you do all that, you should get an answer of 0.9044. And your calculator should look something like that. So the area under the curve, or proportion, as found on the calculator, is 0.9044. Okay. Write the conclusion in context of the problem. So, what does it say? It says, find the probability. So the probability, and let me change this back to a color that I prefer to write in, which is, I'll change it back to red. So here I'll say the probability of max collecting between 30 and $50 in a week is 0.9044. And I like to run to 4 decimal places. The reason being, your book takes all the tables to 4 decimal places, so I think that's a good way to judge how many decimal places we should use. So go ahead and write this down. And we're going to go on, and what I'm going to do is I'm going to use a calculator for 2 more problems and see if you can get them correct. So for this problem, I'm only going to do step 3, and it says at most $32. At most. So is at most a greater than or less than problem? That's what you have to ask yourself. So at most. So I know that it looks something like this when I start writing it out. There's an X, and there's a 32. We just have to figure out what at most means. And at most means less than. At most. So is 33 at most 32? No, 33 is greater. Is 31 at most 32? Yeah. So it's less than $32. So that means that the left-hand limit technically goes on, or the left-hand bound technically goes on forever. For when I did this on the calculator, I think I chose negative 9 million, which isn't negative infinity, because remember this is continuous. It goes from negative infinity to positive infinity. But negative 9 million is about 15,000 or 150,000 standard deviations, and that's pretty far out there. And the probability I got for this was 0.0912. Okay, so my lower bound I used negative 9 million, or another big number. My upper bound is 32, and the mean and standard deviation don't change. The other thing you can do, if it helps you, is also make sure you sketch yourself a quick graph. So it's kind of like I'm doing steps 1 and 2 for you. And I'll graph this real quickly. Oops. Let's do some quick shading here. So I want everything down to the left. So it seems to make sense that it'd be 9% because that doesn't look like a lot on my graph. So it seems to make sense. And let's look at one more example. At least $35. And again, you're going to have to ask yourself, what does the word at least mean? So here I have an X and I have a 35. And if I have to, one of the tricks I sometimes teach students is ask yourself this question. If I need at least $35 to eat something, if I have 36, can I eat? Yeah. If I have 34, can I eat? And the answer is no. So at least is actually a greater than problem. And it's actually greater than or equal to. And it turns out that this whole greater than or greater than equal to is trivial. And we'll talk about it more in class, what the difference is between greater than and greater than or equal to. So again, if I graph this real quickly, I know my mean is 40. I know this is 35. And I know that I have to shade to the right. And when I worked this on the calculator, I used my lower bound, my left-hand bound was 35. My right-hand bound I used 9 min. I just like to pick a big number like I told you before. And the mean and standard deviation is 40 and 6 respectively. I hope this helped. And again, as always, if you have any questions, please make sure you bring them up in class so that I can address the concerns you have. Good luck.